Welcome to Naroj Masters Academy, session 3 of atoms and molecules. Today we'll discuss atomicity and as well as valency. Okay, we'll discuss today atomicity and valency. So, before going to start this atomicity and valency, some interesting fact about elements are there. We'll discuss those facts before going to discuss atomicity. Now, look at here. The sum elements are named based on their properties. For example, if you see here, some elements are named based on their properties. The words from Latin, hydro, the word from Latin, hydro, it means it means water. Okay. Now, what is the name of the water? Hydro. In which language? Latin. So it is a word, hydro from Latin. We call it as a water here. Okay. Now, so the element that combined with oxygen to give water named as hydrogen. So what is the chemical formula actually for water? H2O. And this hydro means what? Water from Latin. So it combines with oxygen. Oxygen. Okay. So here gen and here hydro. So we'll call it as hydrogen. Okay. Hydrogen. So this is the based on their property. This is one fact. It means what? Some elements are named based on their properties. Is it right? Now we see one more. Okay. At one time, people believed that any substance that combined oxygen would be acidic in nature. It means what? If any substance would combine with oxygen, what is the nature of that substance? Acidic in nature. It means what? The word oxy. It is a Latin word. The meaning of oxy is acid. What is the meaning of the oxy? Acid. From where? From Latin. In Latin, we'll call oxy means acid. So, if any substance which combines with oxygen, what is the nature of that substance? Acidic in nature. Why? Because oxy is nothing but acid. If any substance which combines with oxygen, it will become in the nature what we call acidic in nature. Is it clear? Now, if you see, hence the gases which we call as this gas is nothing but oxygen gas. Is it right? Now, place of discovery of element can also play a role in its naming. Okay, it means some names of the elements are based on their scientist names only. Is it right? So, place of discovery of element can also play a role in its naming. So, the gas which was first discovered in the sun, Greek named, okay, for sun is helio. Okay, what is the name in the Greek? Helio. Okay, was named as what we call the name in the elements. Helio is a, what is this? Gas. From the Greek word for sun, it is helio, and we call it as helium. The first gas which is discovered. Okay, so this is the another fact. So these all comes under the facts about the elements. Okay, you can see here the gas which was first discovered in the sun. A Greek word for sun is helio, was named as helium. Okay, now sometimes elements were named to honor the scientist names. Okay, you know very well, very simple. First, one element is there, one not one element. Okay, 101. The position of the element in the periodic table is Mendelevium, based on the scientist name of Mendeleev. Okay, like that, Einsteinium, Fermium, Rutherfordium, and Mendeleevium, different elements are there. So 101 is on the name of Mendeleev. Okay, Mendelevium. What is the position of the element name Mendelevium in the periodic table? 101. Like that, some scientist names also there to honor their names. So, for example, Einsteinium, Fermium, and Rutherfordium, and Mendelevium. It means these are the elements based on their scientist names to honor their names. Is it right? Now, we'll see what is atomicity first of all, and then later we'll discuss valency. In this today's class, we'll discuss about atomicity and as well as valency. Okay, so please focus on this class. You don't think that I am teaching by sleeping. I know very well sometimes I'll get sleep also while teaching as well. That depends on the mood. Is it right? In the sense, if you are in a sleepy mood, don't teach. Now look at here. Atomicity. What is atomicity? Is it right? You can see here. First question. The number of atoms constituting a molecule is known as atomicity. What does it mean? The number of atoms constituting a molecule is known as atomicity. For example, I have an element copper. Okay. So copper valency or copper, it exists in the nature as alone Cu. Is it right? If I'll ask you to write atomicity of hydrogen, hydrogen is a gas, H2. How many hydrogens are there here? 2. If I'll ask you to write oxygen, you will not write O, you will write O2. Is it right? If I'll ask you to write helium, you will write it as He, but you will not write like it as He2. So this is wrong. So He is 1. Copper is also 1. Is it right? Oxygen 2. Hydrogen 2. Is it right? So the number of atoms present constituting a molecule, hydrogen molecule consisted of how many atoms? 2. Oxygen consists of 2. Copper consists of 1. Helium consists of 1. The number of atoms constituting a molecule is known as its atomicity. Is it clear? So let me display the content here based on their atomicity. So helium, argon, copper exist as a single atom. Hence they are known as monoatomic. If the elements are having a single atomic, means a single atom, like copper, argon, helium, etc., what we call them? Monatomic elements. And if they have two means, excellent, that is diatomic. Is it right? So here you can see monoatomic, single, this single and this single. Is it right? Now, molecules of hydrogen, you know very well, oxygen, you can see here, molecules of hydrogen consisting of 2 atoms of hydrogen. Here the atomicity is 2, hence it is known as the diatomic molecule. Is it right? Give example for one more of oxygen is also 2, hydrogen is 2, but ozone is O3. Is it right? It is not diatomic. It is triatomic. And this is diatomic. And this is also diatomic. Is it right? So the molecules which consist of only one atom is known as monoatomic. The molecules which consist of 2 atoms is known as diatomic. Is it right? So remember, very important, each and every point. What are monoatomic molecules and what are diatomic molecules and what are triatomic molecules and so on. Okay. So here you can see the example for diatomic. What is that? Hydrogen consisting of 2 atoms of hydrogen. Then we'll call it as a hydrogen molecule is H2. Is it right? So this is diatomic elements. Some molecules are having three atoms like ozone. Ozone is O3, oxygen is O2. Is it right? So this is diatomic and this is triatomic. Okay. So ozone consists of, you can see here, the molecule of ozone consists of three atoms of oxygen. Here, the atomicity is 3. Hence, it is known as triatomic molecule. Is it clear? Very good. So, triatomic. The number of atom consisting of it is known as atomicity. You know very well. How many atomicities we have discussed now? 3. Monatomic, diatomic, and triatomic. And if some molecules consist of 8, then what we can say? Is it mono? No. Is it di? No. Is it tri? No. Then is it penta? Penta means 5. If 8 are there means, excellent answer, that is octa. Is it right? 7 means hepta. 6 means hexa. 5 means penta. 4 means buta. 3 means tri. Is it right? Different. Okay. Different namings are there. You can remember these all. Very important. If a molecule of sulfur consists of, yeah, you know that molecule of sulfur is consist of 8 atoms of sulfur. Here the atomicity is 8. Hence it is known as octatomic molecule. Is it right? So here you can see the structure of sulfur. It is also called as S8 chrome ring. What we call this? Chrome ring. S8 means sulfur with 8 atomicity. Is it right? So what is the name of this? S8 chrome ring. Okay. It is also called as S8 chrome ring. Did you got what is atomicity now? The number of atoms present in a molecule is known as atomicity. Is it right? So oxygen molecule is having how many atoms of oxygen? 2. So what is the atomicity of oxygen? Very good. That is 2. Atomicity of hydrogen is how much? We know very well. Hydrogen molecule consists of 2 atoms of hydrogen. So atomicity is 2. Is it clear? Now atomicity of chlorine is how much? Maybe it's 1. Why? Because chlorine, if you want to see chlorine gas having atomicity is 2. See, 2 chlorines are required. Is it right? Fluorine also F2. F2 or F, fluorine gas, F2, 2 atomicity. Oxygen, O2. Is it right? So we can identify atomicity now. Now I think we are good at atomicity. Now we'll move to the next concept, call it as valency. The most important concept throughout your chemistry is finding valency. Is it right? If you are good at finding valency, nobody will stop you to balance the chemical equations if you know the valencies of any compound or molecule or whatever it may be. So that depends on the valency only, how to balance the chemical equation and as well as how to write the chemical compounds. Is it right? Shall we move to the next concept? Very good. Now look at here. Valency. What is valency first of all? Why do some elements be monoatomic? So for monoatomic, what should be the valency? Why do some elements be monoatomic? Is it right? Like helium, sodium, etc. Sodium is also having only single atomicity. So we'll call it as monoatomic. Why do some elements form diatomic or triatomic molecules? Like you can see H2 hydrogen diatomic and oxygen triatomic, O3 ozone. Ozone is triatomic, Oxygen is diatomic. So why do elements have different atomicities? Is it right? So different atoms are having different atomicities. Every element has a definite combination capacity that determines that the atomicity of its molecule. Is it right? For example, if you see hydrogen element, it's having different atomicity, and ozone is having different atomicity, and sulfur is having different atomicity. Atomicity of sulfur is how much? 8. So what we call it name is, it name as octatomic. Is it right? Diatomic for 2, monoatomic for 1, triatomic for 3, like different names. Is it right? Then what is valency? Is it right? Every element reacts with other elements according to its combination capacity. For example, very simple. You know what is the chemical formula of water? H2O. Is it right? Now here, we know very well hydrogen is different, oxygen is different. Why two hydrogens are combined with oxygen to form water? Because the combining capacity of oxygen is 2 and the combining capacity of hydrogen is 1. So here O minus 2, hydrogen plus 1. So how many hydrogens can combine with one oxygen? Excellent, that is 2. So hydrogen plus hydrogen, H plus 1 plus 1. So how many hydrogens? These two plus 1s combines together and forms minus 2 with this balance, and then it forms H2O. So this is what we call water molecule, H2O. Is it right? So at the same time, carbon dioxide, if you see, CO2. As we know that the combining capacity of carbon is 4 and combining capacity of oxygen is 2. How many oxygens are required to combine with one carbon? Here 4 is there, here 2 is there. Is it right? So to balance it, multiply with 2 oxygens. That's why O2, 2 oxygens together combined with one carbon to form carbon dioxide. It means that every element reacts with other elements according to its combining capacity. Is it right? Now look at here, A plus B. If they combine together, it forms product AB. We call as its valency. What is valency here? 2 electrons in the outermost shell. All the elements tends to complete the duplet or octet rule. Is it right? Duplet or octet rule is there. Octet rule you will get here. Or octet electron in their outermost orbit. That is a stable. That state means stable means we know very well the number of elements present in the outermost orbit is 8. Maximum number of elements we can fill 8 in the outermost orbit, not more than the 8. Okay, then we'll call it as 8 means octa. So octet rule or duplet rule. Duplet rule is 2, octet rule is for 8, either duplet or octet. Okay, duplet is up to helium, remaining all are having octet rule. Okay, to fulfill that outermost orbit. So very simple logic. Remember, no need to mug up, no need to buttify, no need to what we call mugging up. These all answers for valencies. If you refer the periodic table, logic, first group is having valency 1, second group is having valency 2, and from 3rd to 10th, group number total there are 18 are there. 1 to 18. From 3 to 10, okay, 3 to 10, these are different blocks. Okay, from 1, 2 and these 10 up to 10 plus 12, 13th position next. 13th one is having here in between there are total 10 are there, means up to 12, in between total 10. 13th one is having valency 3, 14th one is having valency 4, and 15th one is having valency 3 now, 16th one valency 2, 17th one valency 1, 18th one valency 0. Is it clear? So, very important. What are these? Valency of those elements in the respective group. If any element which is present in the group 1, what is their valency? 1. The element which is present in the second group, what is its valency? 2. 13th group 3, 14th 4, 15th 3, 16th 2, 17th 1, 18th 0. That's why we'll call them as zero group elements. What we call them? Zero group elements. Okay, zero group elements. Then what about valency electrons? It starts from 1, 2, 3, 4, 5, 6, 7, 8. If in its outermost orbit, if only one electron is there, then that is what we call, these are valency electrons. Only one electron is there, its valency is 1. If two electrons is there, valency 2. If 3 there, valency 3. If 4 there, valency 4. But if 5 there, it means its valency is 3 only. We cannot donate 5 electrons from outermost orbit, but we can gain 3 electrons. Is it right? To know here, instead of how many electrons we need to balance it, to according to octet rule, 8. Is it right? If you want to balance this outermost orbit when only one electron is there, still how many you need to balance it? 7. It is very difficult that to balance us to get the gain 7 electrons, but it is very easy to donate 1 electrons compared to this one. Okay, but whereas if 5 electrons present, if 5 electrons present, then what should be the valency of that particular element? 3. Why? Because it is very difficult to donate 5 electrons, but compared to this one, gaining of 3 electrons is easy. If you gain 3 instead of losing 5, it will become stable. Why? Because already 5 there, 3, total 8. To become stable, we need 8 electrons in its outermost orbit. Is it clear? Like that, you have to remember for 6, 2 valency, for 7, 1 valency. If already 8 are there in the outermost orbit, then what we call? Zero valency. 8 or 2. Here helium is satisfying the duplet rule. For helium, how many elements are there in the outermost orbit? 2 are there. It means it is balanced, stable. Is it right? It is stable. So, what is its valency? 0. That's it. For remaining all elements, we need 8 in its outermost orbit. If 8 are not there, if 7 there, valency is 1. If 6 there, valency 2. If 5 there, valency 3. If 1 there, then valency 1. If 4 there, valency 4. If 3 there, valency 3. If 2 there, valency 2. Is it right? If 8 there, valency 0. Remember, very, very important point about valency. This they do by donating, accepting, or sharing of the outermost orbit with electrons of the other elements. In doing so, they form chemical bond with the other elements, leading to formation of compounds. Okay, find out the valency of sodium. What is its atomic number? Sodium. That's great. Its valence is atomic number is 11. So what write its electronic configuration? As you have studied in your 8th class about electronic configuration, 2 comma 8 comma 1. So in its outermost orbit, how many electrons are there? Only one. So total 11. Sir, I have doubt, sir. Please. Sir, how did you wrote this 2 comma 8 comma 1 here? Again confusion. There are some shells are there. K, L, M, N. We call them as orbits. What we call them? Orbits. Okay, very important point. The capacity of K shell is 2. So before going to give the values of these, you should know that what are shells, subshells, not main shells. Subshells. Okay, the subshells S, P, D, F, and they are having different what we call orbitals. Remember odd numbers. For first orbit, we are having only one orbital, first subshell. And what is the next odd number? 3. 1, 2, 3. Next 5. 1, 2, 3, 4, 5. Next, we have very easy 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 5, 6, 7, 8 are there. So 7 only. Okay. Now remember only one thing. In each box, we can accommodate not more than 2 electrons or 2 Y electrons only. That's it. So for S, how many? 2. For P, 3 2s are 6. For D, 5 2s are 10. For F, 7 2s are 14. Now, S presents only in K. In L, S and P is 2 comma 6, that equal to 8. In K only 2. In M 2, 6, 10, that equal to 18. In N 2, 6, 10, 14, that equal to 32. Okay, maximum number of electrons present in each shell, main shells. Very important. Okay, now remember atomic number of carbon dioxide, sodium is 11. So we'll write as 2 comma 8 comma 1. Okay. So once we'll fill this 8 outermost orbit, then we'll enter into the next orbit. That is, in this we are having only 1. Okay. What is its electronic configuration in the sense 2 comma 8 comma 1 only. Okay. So its electronic configuration is 2 8 comma 1, and its number of elements, the number of electrons present in each shell, you can see here. First shell, K shell. How many are present? 1, 2. Next L cell 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 2 is how much? 10. 10 in the outermost orbit, how many are there? Only 1. So to fulfill or to balance outermost orbit, still how many we need? 7. It is very difficult to gain 7. Okay, but we can donate 1. Is it right? So find out whether the sodium is stable or non-stable. Simply we can say it is unstable now. What we can say it is unstable. Is it right? Yeah, that's great. So to become stable, sodium can give 1 electron to any other, or it has to take how many? That's great. 7 electrons. Is it right? Why? Because in outermost orbit, maximum number of electrons, how many we can fill? 8. So how many are there in its outermost orbit? Only one. Still how many need? 7. So instead of gaining 7, okay, how many we can lose? 1 is enough to lose. Is it right? To become stable, sodium can give 1 electron or take 7 electron. Here you can see, instead of giving this 1 electron, and achieves their inert gas electronic configuration. Okay, so sir, why we need to reach to inert gas in the table as per their atomic numbers? Okay, so if they are stable in the outermost orbit, then valence is 0. Okay, so it is easy to give 1 electron instead of gaining 7 electrons. For sodium, the nearest inert gas is neon. Okay, so valency of sodium is how much? We're donating 1 electron. It means valency of sodium is 1. Is it right? Very easy concept. Valency of chlorine, atomic number is 17. Okay, so its electronic configuration is 2, 8, 7. Is it right? So in outermost orbit of this chlorine, how many electrons are there? 7. So to become stable, how many we need? Is it stable now? No. Still, how many we need? We require more 1. Why only 1? Already 7 are there. Is it right? To become stable, how many we need? Total 8. So balance is 7 plus 1. So gain the electron. It also chlorine will gain 1 electron to become stable. So chlorine has 7 electron in its outermost orbit or shell. Okay, it needs 1 more electron to achieve the 8 electron configuration. Since the one chlorine atom gains 1 electron to achieve the inert to gas electron configuration. So the electrovalency of chlorine is 1. So what is the valency of chlorine? 1. What is the valency of sodium? 1. Is it right? So I will display here and valencies of some common metals and elements. So metals are electropositive, whereas metals tends to give away electrons. Always metals can donate the electrons, but whereas non-metals always gains the electrons. Is it right? Element and then symbol and then valency. First lithium, atomic number 3, symbol L, small I, valency is 1. Why? Because it belongs to first group. Next to sodium, Na, its valency also 1. Is right? Potassium, K, its valency also 1. Okay. Next silver, then its symbol is Ag, very good. So its valency is also 1. Next copper, Cu, its valency is, yeah, excellent answer. That is, it depends on the, sometimes it will get 1, sometimes it will get 2. For cuprous, it is 1. For cupric, it is 2. Is it right? You can see here, for cuprous, its valency is 1, and for cupric, valency is 2. Is it right? Mercury. Mercury means it's a metal. Very good. But liquid in state. Hg, is it right? Its valence is Hg. Next, its name is Hg. Its valence is also 1, 2. That depends on the bonding with which metal it is reacting. Is it right? Metal or oxides. So mercurous is 1 and mercuric is 2. Like that. Next element, symbol and valency. Magnesium, Mg, symbol, and its valency is 2. And then Next is calcium, Ca, its valency also 2 because these elements belongs to second group. Next zinc, zinc is Zn, its valency is 2. And then next iron, iron is Fe, is it right? So the what is the name of the iron in from Latin? Ferrum, is it right? And then valency is 2 comma 3. And then next is ferrous and ferric acid. The 2 comma 3 means ferrous is for 2 and ferric is for 3. Next aluminium. What is the meaning of, what is the name of the symbol aluminium element? Al. Yeah, very good, Al. And next, what is the valency of this? Very good answer, it is always 3. Is it right? Very, very important. So valency of some common non-metallic elements or non-metal elements also. Non-metal elements are electronegative. As we know that just now we have discussed about electropositive elements. Electropositive means metals, whereas non-metals electronegative elements. And then non-metal spins accept or shape or short electrons. Accept or share electrons. Okay, non-metals. Element symbol valency. Hydrogen is a gas, non-metal. H valency is 1. And then fluorine, F, its valency is also 1. And then what is this chlorine? Chlorine is also Cl, its valency is also 1. If 2 chlorines are there, then valency is 2. Then barium, is it right? Or bromium, bromine. Bromine is Br. Don't get confused. So bromine is Br, and then its valency is also 1. Then iodine. Iodine is I. Its valency is also 1. Okay. Next oxygen. Valency is 2. Is it right? Very good. Now last. Let me finish here. So and note down in the next slide all important symbols, plus and minus. Okay, very, very important slide. This and next slide. So here you can see element, symbol and valency as well. Sulfur, yes, valency is 2. And then nitrogen, N, valency is 3. And then phosphorus, F, phosphorus P, not F. Is it right? F is for fluorine. And P, valency is 3. And then carbon, carbon is C, valency is 4. Is it right? Now last slide, very important, ions and polyatomic ions. Okay, ions and polyatomic ions. What is an ion? So compound formed by metal and a non-metal contains charged species are known as ions. We call them metal and non-metal is nothing but you can call it as ion. So here three types of ions are there. Ionic compound, covalent compound, metallic compound. Ionic means reaction between metal plus non-metal is known as what we call ionic compound. Is it right? Very, very important. Now look at here. Covalent bond, metallic bond, ionic bond. 3 bonds we'll get in the next future classes. So here, a negatively charged ion is called anion and the positively charged uh, ion is known as cation. So what define anion? Define anion is also very, very important. What is anion? A negatively charged ion is known as anion. And what is cation? A positively charged ion is known as cation. Anion is negatively charged particle and cation is positively charged particle. Is it right? So very, very important. For example, sodium ion is written as Na plus. Sodium ion is Na plus. Is it contains cation or anion? So we'll call it as a cation. Okay. Then if we see chlorine is ion is named as Cl minus, then what we call it as anion. Is it right? Sodium ion is cation, chlorine ion is anion. Why? The negatively charged particles are known as anion and positively charged particles are known as cation. If you see magnesium, Mg plus 2 will write. Why? Because its valency is 2. So cation or anion? Cation, very good. Now I will display here very important table that will help you in future as well. Okay. So for example, sodium ion is written as Na plus and chlorine is as Cl minus. So valency of some elements very, 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 very important. Okay. You have to remember this all, then only you will become the perfect person in this chemistry. How to write the balanced chemical equation. Very, very, very important. Very, 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 very important. Okay. So you have to remember as well, not only note down. Noting down is not enough. Okay. Valencies. From this slide to next slide, all are very, very important. What is an ion? So you know already very well. A compound formed by a metal and a non-metal contains charged species. Is it known as ion? Is it right? You can see here. Charged particles, positive or negative charged particles are known as ion. Okay. If positively there means cation. If negative there means anion. Is it right? Very, very important. Positive means cation. Ion means what? Some charge. Is it right? A compounds formed by metals and non-metals contain charged species. Charge, that's it. Either negative or positive are known as ions. The charged species are known as ions. A negatively charged is known as anion and positively charged is known as cation. Note down this table. Some common simple and polyatomic ions. Poly means the what is the net charge? Cation symbol and anion symbol. 1 unit net charge. 1 unit means only 1 plus. Okay, no need to write plus 1. Plus is enough. For example, Na will write as Na plus here. Is it right? If you see calcium, Ca plus 2 will write, not plus. That is what we call net charge. Net charge. For the elements which are having net charge as 1 unit, their cations in the sense positively charged and symbols, and anion means negatively charged and their symbols. Hydrogen cation H plus. Okay. Sodium cation Na plus, and then potassium cation K plus, and then silver cation Ag plus, copper cation Cu plus, star mark there here, so note down that. Ammonium cation NH4 plus. Okay, now hydrogen is different, hydride is different. Hydrogen is H plus, hydride is H minus. Chloride, hydride, next chloride, Cl minus, and next is bromide. Bromide is Br minus. Next iodide, iodide is I minus, and next is hydroxide, OH minus. Next nitrate, NO3 minus. Is it clear? These are having how much charge? 1 unit charge. Now 2 units. Magnesium, Mg plus 2. Calcium, Ca plus 2. Zinc, Zn plus 2. Copper plus 2, Cu plus 2. Here I gave one star mark. So copper can exist either unit 1 charge, and copper can exist in unit 2 charge. Is it right? It's having some property like having 1 charge or 2 charge. Iron, star mark again, Fe2. Okay. Oxide, these are anions. OH minus, maybe O2 minus. Why? Because this is only oxygen is there, OH is not there. OH means hydroxide will come. OH oxide, O2 minus or minus 2. Why? Because valency of oxygen is 2. O2 minus. Sulfide. Sulfide is S minus 2. Is it right? Next, sulfate. Sulfide is different, sulfate is different. Sulfate is SO4 minus 2. Next, carbonate. Carbonate is CO3 or CO2. Is it right? CO3 minus 2. And next is dichromate. So its answer is Cr2O7 minus 2. Is it right? Only few left related to unitary charge or charge unitary. Is it right? First one is aluminium. Al minus 3. Very good. Next is iron. Iron is Fe3. Very good. Nitride N plus N minus. Nitride is N minus 3. Is it right? As there we are getting cations with plus symbol and with minus symbol. Nitride minus 3. Okay. Phosphate. Phosphate is PbO4. PbO4 only, na? PO4 phosphate, not Pb. Pb is lead. So PO4 minus 3 phosphate. Okay. Pb means lead. Okay. Very, very important here. Valency of an ion is equal to the magnitude of its charge. Okay. Valency of oxides not O2 minus. It is 2. Okay. Valencies. So let me stop here for today. In the next session 4, we'll discuss about atomic mass. Atomic mass. Okay. In this session, what we have discussed so far? Atomicity, valency, valency electron, and other things also we have discussed here. So this H plus indicates plus 1 valency, here valency 2, here valency 3. Is it right? Very, very important. Okay. So let me stop the session here for today. And in the next session 4, we'll discuss about atomic mass. Okay. See you in the next session. Take care.